What you are looking at right now should be on fire. It is not. This panel scores 0 on the Federal Flame Spread Test. Not low, not fire-resistant, 0. The highest possible rating, equivalent to bare concrete and structural steel. It also costs less per installed square foot than what is inside your walls right now. 8 million square feet of this material went into the 2008 Beijing Olympics. That same year, the American construction industry used none of it. There is a reason magnesium oxide board is not sold in this country. The reason has nothing to do with whether it works. On October 10, 2018, Hurricane Michael made landfall on the Florida Panhandle as a Category 5 storm, with sustained winds of 170 miles per hour. The strongest hurricane to strike the continental United States in 50 years. In Panama City, Florida, a 3,800 square foot, 2-story home belonging to James and Moira Funk sat in the path of the eye wall for 3.5 hours while its owners were evacuated. When they returned, the siding showed damage and some roof metal had shifted, but the structure was standing. The walls were intact. No water had penetrated the roof panels, even where the metal above them had failed. Tyndall Air Force Base, built to military specifications and located nearby, sustained damage requiring over $1 billion to rebuild. The Funk home was built with a material patented in 1867, used in Olympic construction in 2008, and unavailable at any building supply store in the United States today. What follows is an account of how that came to be. Stanislas Sorel was born the son of a clockmaker who could not pay university tuition. He taught himself chemistry and metallurgy, and 30 years before the moment that concerns us, he had already made his first lasting contribution, inventing galvanization, the process of coating iron in molten zinc to prevent corrosion. In 1867, at the age of 54, Sorel was working in Paris, mixing a slurry of finely powdered magnesium oxide with concentrated magnesium chloride solution. The material that hardened in the crucible measured between 10,000 and 12,000 pounds per square inch in compressive strength. Portland cement, the prevailing industry standard, achieves 7,000 to 8,000. Sorel published his findings that same year in Comptes Rendus under the translated title, A New Magnesian Cement, Stronger than Portland, More Elastic than Portland. He was not discovering something without precedent. The Ming Dynasty sections of the Great Wall were built with dolomitic lime containing natural magnesium compounds. Roman concrete, poured into foundations still standing 2,000 years later, was rich in volcanic pozzolana with elevated magnesium content. The Brooklyn Bridge, completed in 1883, used Rosendale cement derived from dolomitic limestone, containing 14 to 30% magnesium. Magnesia had been a structural material for millennia. Sorel isolated and documented it. He died 4 years after publication. The chemistry he identified would later be reinforced with fiberglass mesh, compressed into flat panels, and subjected to furnace testing at 1,900 degrees Fahrenheit, and survive. The following is a summary of documented test results, not manufacturer claims. On February 17, 2022, at Intertech Laboratory in San Antonio, Texas, a wall assembly built with double-layer 12mm MgO board on both faces of a steel frame entered an ASTME 119 furnace, the federal standard for structural fire resistance. Temperatures exceeded 1,900 degrees Fahrenheit and were sustained for 2 hours. During the test, magnesium hydroxide within the panels decomposed, releasing approximately 30 pounds of water vapor. The material was not merely resisting heat, It was actively suppressing it. When the furnace opened, the panels had charred on the surface. The structure was intact. Fire hoses applied to the superheated wall produced no water penetration. Structural strength retained, 94%. By comparison, Type X gypsum drywall, the fire-rated product standard in American construction, carries a maximum 1-hour rating. At approximately 400 degrees Celsius, it loses structural integrity and crumbles. The base compound of MgO does not melt until 2,800 degrees Celsius. At Curtin University in Perth, Australia, researchers Wu Chen and Hong Hao spent 4 years firing 2x4 timber boards from pneumatic cannon systems at wall panels at 40 meters per second, approximately 90 miles per hour, the speed of debris in a major hurricane or tornado. OSB-skinned structural insulated panels, the standard product, suffered what the researchers described as localized punching shear failure. The board passed through the wall. MgO panels reinforced with steel wire mesh stopped penetration entirely. At UC Berkeley, Professor Khalid Mosalam, director of the Pacific Earthquake Engineering Research Center, conducted cyclic push-pull seismic testing at the Richmond Field Station. The results, published in Wood Design Focus in 2012, showed SIP construction with MgO panels withstanding 50% more seismic force before failure than conventional wood frame construction. In moisture cycling tests, 25 cycles of complete immersion followed by complete drying, OSB lost 40% of structural strength. Gypsum drywall lost 52%. MgO board lost none. On the ASTME 84 flame spread test, which runs from 0 to 450, with Class A materials scoring between 0 and 25, gypsum drywall scores 0 to 15, and OSB scores 76 to 200. MgO board scores 0 for both flame spread and smoke development. Between 2009 and 2015, MgO boards using magnesium chloride binders with free chloride content of 5 to 10% flooded international markets. Quality-controlled boards maintain chloride content below 1%. In high-humidity climates, the substandard products absorbed moisture and released corrosive brine. In Denmark alone, resulting damage reached approximately 300 million British pounds. Steel studs corroded. Zinc flashings failed. The failure, specific to one class of inferior product from inadequately controlled manufacturers, was attributed broadly to the material category, including boards that never contained excess chloride and that passed every test administered to them. A DuPont technical paper from February 2024 noted that the chloride issue is fully resolved through proper mix design and quality control. That distinction does not appear in industry warnings. Even where building officials grant approval, additional barriers follow. Appraisers require comparable sales data. With almost no MgO homes built in the United States, that data does not exist. Fannie Mae guidelines allow lenders to decline non-traditional construction when sufficient information is unavailable. The result is higher down payments and portfolio loans in place of standard mortgages. Insurance actuarial models have not been updated for MgO. No major insurer offers documented premium reductions for verified fire or hurricane resistance. The IBHS Fortified program, which has issued over 70,000 storm resistance designations in 31 states, does not specifically recognize MgO panels. No national contractor training exists for the material. Builders unfamiliar with it bid it high or decline the work. Demand remains low because familiarity remains low, and familiarity remains low because demand is low. A half-inch MgO panel costs between $1.50 and $3.50 per square foot. Gypsum drywall costs between 30 cents and 70 cents. The material level comparison is accurate and routinely cited. It does not account for what a structural insulated panel replaces. ASIP integrates structure, insulation, air barrier, and interior finish into a single component. When used in construction, it eliminates separate stud framing, cavity insulation installation, drywall installation, most air sealing labor, and a significant portion of HVAC sizing. RS means construction data shows SIP framing requires 55% less labor and 41% lower erection cost than 2x6 stick frame. A 1,200 square foot home frames in approximately 150 man-hours with SIPs versus 750 with stick frame. In 1867, a self-taught chemist in Paris mixed powdered oxide with salt water and produced a compound stronger than anything then available. He published 3 pages of findings. He died 4 years later. 159 years after his patent, the material he documented has no prescriptive code pathway in the country with the highest construction spending in the world. The chemistry has not changed. The market it would displace generates $29.5 billion a year. Somewhere in a neighborhood that was hit by last year's hurricane or last year's wildfire, a house is standing that the surrounding structures are not. It was built by someone who found their way through the existing approval system. The material performed as the test results said it would.